Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Alright, in this problem we have here, we have two particles accelerated from rest through a potential difference while in a magnetic field. We are told that both particles travel through the same potential difference and the same magnetic field, and that both particles have the same charge. So these equal the same for both particle 1 and particle 2. Okay, and we are given the radius for particle 1. I'm going to differentiate between the two by calling them P1 and P2. So the radius for particle 1 we know. We want to find the radius for particle 2. That is our unknown in this case. R2 is unknown. So now we need an equation that has all of these things in it. And we do have one, thankfully. The other thing we are given before we get started is the masses of both M1 we know and M2 we know. So the equation that we have that puts all of these things together is M, the mass, is equal to charge times the radius squared divided by 2 times the voltage, the potential difference, times the magnetic field squared. So this is the equation we want to use. So how do we use this, knowing R1 and M1 and M2, how do we use that to get to R2? So because all of these things are the same, the ratios of mass to radius, so M1 to R1, will be the same as the ratio of M2 to R2. And if you don't see the relationship between these, it might become more apparent as we start working through. So this is the physics bit of this problem. The rest of it is simply algebra. So another way to say this, or to see this, would be that if Q, V, and B are all the same in both cases, meaning that they don't change between the two, that means M has to change as R changes. And they have an inverse square relationship because this R is squared. So as R changes, if R is getting bigger, all of this stays the same. We can't change any of that. If R is getting bigger, then that means this M also has to get bigger. So we can say that they are proportional. So R is proportional to M. And that being the case, if we were to move this R squared, you could write this as R squared as well. It doesn't change the ratio because this is a ratio. You can see that if you just divide by R, you'll get M over R over here, which is actually what we want to do, because if all this is constant, we can get everything that we need on one side and everything that's constant on the other side. The only reason we can't do that with the M is because the M is different, that they have different masses for particle 1 and particle 2. Everything else is the same between both particles. So now we can rewrite this equation, moving this R over. We have the mass divided by radius squared is equal to Q 2VB. And this is squared, of course. So now because all of this is the same, it doesn't change, it doesn't matter what we call it, we can lump it all into one sum. So we can say that this now is equal to c for a constant. All of this is just a constant, so we can lump it all together into one, just to make it a little bit easier to do the algebra here. Okay, so now using this, we can write two equations, one for particle 1 and one for particle 2. So we have m1 divided by r1 squared is equal to that constant, c, which is all of this stuff. And we know that m2 divided by r2 squared is also equal to this same constant, which is all of this stuff, once again. Because they are both equal to the same thing, we can set them equal to each other, because they are both equal. And this is basically just proving what I surmised here. So this is the math proof for this statement. That's where I got that from. So now we can write, we want to find R2. So we can write, doesn't matter what order we write these in, m2 divided by r2 squared is equal to m1 divided by r1 squared. So everything is known in this equation except for what we want, which is r2. So now, to get r2 on its own, there's a couple different approaches you can use. You could multiply both sides by r squared and then divide both sides by this. Or you can divide both sides by this m2 and then just flip both sides. Either way you'll get the same answer, or the same end, which turns to be, you have r2 squared so now we have this m moved over and then flipped. We have m1, or this would be m2 multiplied by r1 squared divided by m1. And we know all of these, but this is for r squared, so we need to take the square root. r2 is equal to the square root of mass 2, mass for particle 2, times the radius for particle 1 squared divided by the mass for particle 1. And that's your answer.